Now I'm going to walk you through a few things just to get you started well on this rolling down the river activity. This is on page 2 of your guided notes, pages 2, 3, and 4. So the story is a farmer has a new field that he planted corn. There's a river along the east side. And he looks at it and he's not sure he really should harvest it, if it's worth the effort, because some of it's not good. There's some areas that are good and some that are not. So he decides to take a sample of 10 plots. And the first idea he had is just to conveniently drive his tractor out of the barn. And when he drives his tractor out of the barn, he's going to sample 10 plots somehow. So what do I have here? 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That would be a sample of 10 plots. So if he drives his tractor in the way that I did, these would be the 10 plots from his sample. See if I got it right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that would just be one way to drive the tractor through there. You can drive the tractor any way you want to, but the idea is to get 10 plots conveniently, quickly, and these would be the 10 plots that would be in his convenience sample. So that's one way to sample. You might figure out, if you know anything about agriculture at all, that that's not the best sampling method, mostly because the river tends to be affecting the corn from the right to the left. And if you know anything about farming, you might guess that perhaps the corn on the east side is better than the corn on the west side because it gets a little more water and liquid. If that's the case, then perhaps his convenience sample is not the best sample because it might be the worst corn from the field. So if that's true, maybe he didn't really get a really good representative sample. So he comes to us as AP Stats students, and he wants us to do a random sample. So here we have the first opportunity to do a random sample, and we're going to do what's called a simple random sample. That's actually the third method we used with the random rectangles. That was called a simple random sample. We had a list of 100 rectangles, and we randomly picked 5. In this case, we have essentially, if you want to number these, 1 through 10, and then 11 through 20, and then number these all the way down to 100. You could imagine that these plots could have been numbered from 1 to 100 like this. And if that's the case, then what we can do is do a random integer, 1, 100, and do it 10 times. And that would be our sample of 10 randomly picked plots. So let me get out my calculator, go to Math, Probability, Random Integer, 1, 100. And you'll just have to trust me on this. My first random number was 43, so 20, 30, 40, 1, 2, 3. This would be 43. My next one is 58, so 10, 20, 30, 40, 50, 60, 59, 58. This would be that one. And on we go. 68, so I guess that would be the one right underneath it. And the idea here is to keep doing that until you get 10 plots chosen. That will be our simple random sample of 10 plots. Then we have this other method called a stratified sample, where every vertical column is going to be a strata. So this is going to be a little different because now we're just going to pick one of the plots from these 10 plots in every vertical column. So we really only need random integer 1 to 10. So if we do that, and let's say 5 comes up, well, that means that the fifth one of the first one is our plot. If the next random integer that comes up is a 7, well, then we pick the 7th one from the second vertical column. And we work our way across until we get 10 that way. That ensures that you're going to get 1 from every vertical column. And then the fourth method is we're now going to consider each row to be a strata. And we're going to pick one of those 10 plots in every row. And that will be, so if we got like the 10th one, and then maybe do random integer, we got 4th one, and then random integer, we did the 7th one. We just work our way down and pick one randomly from the 10 that are in each row. And so when we're done, we're going to have 10 plots from each of these 4 methods. And what I will do then is after you get these done, I will show you what the actual yield is. And so you'll see 100 yields from 100 plots. And what you'll do then is under each of these methods, you're going to figure out what your estimate would be for the field. So I'll let you do the math. It's really just arithmetic. When you add up your 10 plots, that will just be 1/10 of the entire field. So all you'd have to do is take the sum of the 10 plots times 10, and that will be the estimate for the entire field. And you're going to do that. You're going to find these 4 estimates for the entire field, and you're going to enter them into a form. So you'll find that link in Canvas. Once you get these 4 estimates, you'll submit them into the document, and then hopefully in a time in the near future, we will look at these together and see which of these methodologies gives us the best method. Now, actually, I see if you have an electronic copy of this, the link is right here, but I also have this link in Canvas that you can enter as well. You're going to be going to StatCrunch to enter that. So hopefully that will work, and we'll talk to you later.